Welcome to Spark Academy, dear students. I am Nityanand Ghosh, physics faculty here. Today, the other day I discussed about errors. Today I will be discussing, revising just 1 or 2 minutes what are the different types of error we have discussed. Then we will be solving some numerical problem. As I told you before, error is nothing but some mistakes in doing measurements. Measurement should be very precise. Suppose you are doing experiment in the lab, if something here and there goes wrong means it is okay. But suppose you are there in research lab, the other day you have seen that Skyroot company has launched a rocket, slight deviation in time and all, no, it will cause huge loss, it has to, that satellite has to go and orbit around the earth, any initial parameter, any small mistakes that will cause havoc, and then there will be a problem. So it is our human endeavor that we have to minimize the error as much as possible. We have to minimize the error. Now, what are the different types of error which normally we are there, and then how to actually correct it? That we have to see. So, so last class, I told you there are different types of error is nothing but gross error, systematic error, random error. There are other errors in statistics, probable error and all. But these are the main initial errors: gross error, systematic error, random error. So gross error is nothing but it is caused by human error. This is okay. In misreading instruments, incorrectly recording data, improper setting of equipment. See, you have to know whatever instrument, let it be vernier calipers, let it be screw gauge, let it be spirometer, you have to know how to do measurements with this small instrument. You have to know how to find out the least count. See, least count, differs from apparatus to apparatus. Same apparatus, suppose screw gauge is there, I can have 2-3 different types of screw gauge having different, least count, more least count is the smallest division which an instrument can measure, So more smallest division it can measure, more precise that instrument is will be measuring that particular measurement. So sometimes we have to, it is the instrument, incorrectly we are recording, the measurements. So that is nothing but your gross error. Now systematic error. Systematic error is nothing but one is your instrument error. I told you, it is a faulty calibration, poor equipment design, zero error. Zero error accurately you have to find out. The zero of your measuring device and zero of the vernier, it should coincide. If one is above the other and all, it will be an error. So you have to quantify that. Suppose it is 3 division of 0, so you have to subtract 3 division. If that particular 0 of the vernier is below, so you have to add 3 division. So like that you have to quantify. And sometimes calibration. Suppose if they say that, see, 2 centimeter is equivalent to 4 volt. So 8 centimeter will be how many volts? Like that calibration chart will be there. Calibration will be there. If those things you are not following, then there will be an error. Sometimes environmental errors are there because of temperature, humidity, vibration. Sometimes, when you are measuring, particularly suppose you are measuring the direction using a tangent galvanometer, or you are measuring using a compass and all, there should not be any vibrations, or let it be any meter also, there should not be any vibrational meters are there, then if any vibrations are there, that also will cause wrong measurements. Then there will be parallax errors will be there. Observational error. Parallax error means whenever you are doing measurements, you have to do it normally, not at some angle. Suppose you are measuring the angle of, let's say, prism, angle of prism, and you need to find out R1, R2. Because if somebody asks you determine the refractive index of a given prism, this is the formula you are using: sin A plus dm by 2 by sin A by 2. So you need to find out angle of prism accurately and dm also. Angle of prism is 60 degree, all of you know, equilateral triangle, but you are doing a experiment, no? So it may slightly vary. So then you will get the correct reading. Minimum deviation also accurately you have to find out. Then the refractive index. The refractive index of a glass varies from 1.5 to 1.7. If you get 2 or 2.2, that is wrong actually. So measurement has to be. So when you are measuring the angle, it should not be angular measurements. It should be normal. Instead of 15.5 degree, who knows, you may get 17 degree. That will be wrong. So parallax error will give wrong measurement. Methodological error, some methods wrong. Sometimes you measure the temperature. Suppose you get fever, you take one thermometer and put below your armpit. That is a wrong measurement. Whenever you are putting under armpit, you have to add. Doctor says that you have to add 1 degree more. Correct way is you have to put that thermometer below your tongue. Then accurately you can measure. So these are the different types of random error. Will be nothing but it will be mixed all those things, and sometimes there will be a resolution also, resolution limit error also there. Suppose you are finding out resolving power of a telescope experiment, you are finding out. So resolving power is nothing but it is the ability to distinguish two nearby points as separate points. So that has to be distinguished by the telescope. Now telescope, when you are adjusting, that slit should be such a width that that particular angular variation should be within that resolving limit of the instrument. And then what you do, suppose a crosswire is given. Suppose they ask what is the distance between two vertical crosswire, two horizontal. So what you need to do, crosswire will have both horizontal and vertical, no? So you have to adjust the instrument in such a manner that all the vertical crosswire will vanish, only horizontal will be seen, and vice versa. So that very accurately you can find out the distance between two wires. So now you need to calculate there are some calculations formula, and then we'll solve some problems, Now absolute error. What is absolute error? Absolute error is nothing but it is the difference between measured value and true value. Sometimes true value will be given, sometimes true value will not be given. Sometimes they will give what is the rigidity modulus of a copper wire. Already suppose they have given. Then you find out in the lab rigidity modulus of a copper wire. There is some formula. Pi p r power 4t by 8v. Some formulas will be there. Another 16 pi m into d square minus l square, like that a to the power of 4 into t2 square minus, some formula will be there. So either you are finding out the viscosity or you find out the rigidity modulus, some formulas will be there, and true value will be there. What is the viscosity of, let's say, oil or liquid will be given, then you find out, then you compare. Surface tension also like that, rigidity modulus also like that. Suppose it is not given, that time what you do, you find out the average value of all the observation, and that average value will give true value. So actually absolute error is nothing but measured value minus true value. I will explain with the help of some example. Now, this is the formula for mean absolute error. What is mean absolute error? It is sigma I is equal to 1 to n. AI can be A1, AI can be A1 or A2 or A3 or A4. Suppose you are finding out two observations. Then what you do is, this A1, A2, A3, A4 ka average you find out. Then from that average will be A mean. That average you subtract each value. Mean value minus A1 minus mean value, A2 minus mean value, A3 minus mean value, A4 minus mean value. Then you add them, then again you divide by 4. N is equal to 4. because only 4 values are there, no? Here AI is each measured value, A mean is the average value, and N is the number of measurements. Okay. So then after so relative error is nothing but the mean absolute error by true value will give you relative error, and percentage error will be nothing but into 100. So let us, with the help of some example, let us find out. Okay. Now, let's say this, there are certain rules for addition, subtraction and multiplication error, because when you have too many parameters, error will propagate. Propagate means there is a chance that error may increase. So it is your endeavor, it is your hard work, it is your precise measurement technique that to minimize that error as much as possible. Now, let's say addition and subtraction. Suppose when adding or subtracting quantity, the absolute error in the final result is equal to sum of the absolute error of the individual quantities. Now, suppose this is explained with the help of one example. Suppose A is nothing but error in A plus error in B will give you the total error. For example, if the length and width of rectangle are measured as, this is the A stands for length, B stands for breadth. They are asking you semi-perimeter. Actually, what is the perimeter means? Sum of all sides. So for a rectangle, what is the perimeter ka formula? 2 into L plus B. Semi-perimeter will be just length plus breadth. So what you should do is, you should add this 5.4 and 3.2 first to express it in a proper manner. What you should do, you should add 5.4, these are the absolute values, 5.4 and 3.2. So 5.4 plus 3.2 first you have to add, then these are the error, plus or minus. Means there can be 0.1 more or 0.1 less. So this is actually A, this is del A. This is B, this is del B. So what you do, this you add, 0.1 plus 0.1 will give you 0.2. So perimeter of rectangle is given by this particular format. Okay. Now let's say multiplication or division. Let's say you are asked to find out what is the area of a rectangle. Area of a rectangle, you know that it is length into breadth is area. Suppose A stands for length and B stands for breadth. So now, one important thing you have to keep it in mind, if it is multiplication followed by division and all, and A cube plus B, A cube into B into C cube by D4 into some Q, you treat, don't bother about multiplication, don't bother about division. You treat each one separately and write down error and add them. If any power is there, you multiply that power in front. That's it. For example, rectangle is length into breadth, no? A stands for length, B stands for breadth. So when you are writing down in error form, Z will become del Z by Z. That del Z is nothing but error, small error in Z. So del Z by Z is equal to, A is nothing but del A by A. You commit some mistake in area, so that is del A by A, plus B is del B by B. Okay. So now this is how you find out. So what you need to do is, you substitute. What is del Z by Z is equal to del A by A. Del A is, this is your del A. 0.05 is your del A and 0.1 is your del B. So del A is nothing but 0.05 by A. This is your A and this is your B, absolute value. So a 2.5 plus error in this is 0.1 divided by 4. 4 is nothing but 4 is the breadth of the rectangle. So then you calculate this, add them. This is the actually relative error. Okay, you can write down in percentage form also. Okay, that is so this is how you find out absolute error, okay, relative error, okay. Now, what are the rules for, error rules followed in power? Power means, suppose z is equal to a power n is given. There are two techniques. Either you multiply by applying log on both sides. Wherever e is there, you multiply, you apply log on both sides. Or if any power is there, you multiply that power in front. So what you need to do is z, z is equal to a to the power of n. So del z by z is equal to n into del a by a. So this is how you should. We'll do one problem and then you will come to know this one. So this is one numerical problem. What is a numerical problem? One student measures a diameter of a wire. Diameter of a wire, actually you have to measure with the help of a screw gauge. I hope in your physics lab you might have measured the diameter of a wire. With the help of screw gauge you find out. Let's say a student measures the diameter of a wire and the measurements are, first time he measures 0.5 mm, second time 0.52 mm, third time 0.49. Next time 0.51. So all the readings are different. Then you have to find out find the mean absolute value and the percentage error or mean percentage error. So what you do is first add this individual measured value. So individual measured value, first add them and you divide by 4. So this will give you average of this 4 value and you round it off. You round this 5, add 1 to this 0. So it will become 5, 1. This is your mean value. This is your mean value. Then what you do, mod, why you are putting mod means if there is any minus, it will become plus. What you do, individual value which is been measured, that you subtract from this average value. So 0.50 minus this 0.51. 0.51 is the true value, acting like a true value. Next, 0.52 minus this 0.51. Similarly, 0.49 minus 0.51. Similarly, 0.49 minus 0.51, you will get this value. Then again you find out the average of this value. Next slide. So you find out the average of this value. So you add them by 4. So this is your mean absolute error. Then percentage error is nothing but mean absolute error by the true value. True value you got initially, that average value, into 100. So 1.96% error is there. Now if it is coming within the tolerable limit of that instrument, then it is okay, fine. Okay. Now another example. The length of 2 rods are given. Find the sum of the lengths and the corresponding absolute error. So in this you know that this is actually L1, this is its error value. This is actually L2, this is its error value. So first what you do, you first find out the absolute value of the length. L will be equal to L1 plus L2, that is 12.6 plus 8.3, this value, and del L is nothing but this is del L1, this is del L2. This is your del L1 and this is your del L2. So you put them and then you add them and then you write down in this format. This format says that this is the total length which is measured. It can be 0.3 more or 0.3 less. Okay. This is another similar type of problem. Student measures the masses of an object and you have to calculate absolute error, relative error, percentage. Similar one problem we have discussed. Okay. So now let us calculate this one. Let us discuss this problem. What is this problem? See, the radius of a cylinder is measured as, this is R, this is H. Height is H. Radius of the cylinder is measured as this. This is R, this is del R. And this is the height. This is height and this is del H. This is H, this is del H. Now, You know volume of a cylinder का formula, it is pi r square h. Pi r square h means V will be equal to pi is nothing but 3.14 into your actual R will be is 3.2, let's say 3.2 whole square into H. So this will give you, next slide mein, this will give you 334.77. Okay, 334 point, this will give you 334.77 is the value, actual volume, volume of a cylinder. If you use the formula, but there are some error. Radius can be 0.1 more or less and height also can be more or less by 0.2. So what is its effect in the volume? You have to find out del. So actually this, you know, this you have to write down in this fashion. V del V by V should be equal to, don't bother about pi, constant don't bother. R square you write it as 2 del R by R plus del H by H. So this is the formula you are going to use. To calculate the del V is nothing but the error in measuring volume. This is the actual volume. So what is del R by R? Del R by R means what is del R? 0.1. What is R? 3.2. You get 0.03. Then what is del H? Del H is 0.2. What is H? H is 10.4. So if you divide that, you will get this value. Now these two values you substitute in here. Del R by R, that is 2 into 0.03 plus del H by H is nothing but 0.02. That will give you del V by V. So next slide it is there. Del V by V is 2 into del R by R plus del H by H. You substitute the value, you will get this. So del V will be equal to this value into V. Already this value we got 377. So V value you substitute, V value is nothing but your 3 pi r square H you do. Here they have used the formula pi into r square. R is 3.2 whole square into H. H is nothing but 10.4. It is given in the previous slide. So you will be getting del V into 0.08. So directly you will be getting 26.8. So how you should write down the volume? Volume you should write normally by using the formula you got 334.77, that plus or minus 26.8. This is how you should write. Then this is another formula. This is the same rectangle. Your length is given, breadth is given. You have to find out the area of the rectangle with error. Similar type of problem we did once. Now let us discuss this question. The distance covered by a body in time. This is your time. This is time because it is measured in seconds. And this is your velocity and distance. Distance is 40 plus 0.4. So calculate the speed. So distance is 40 plus or minus 0.4 meter and time is 5 plus or minus 0.6. You know speed is equal to distance by time. So distance is absolute value is 40 by 5, 8 meters per second. So how you write down in error form? Del V by V. This is velocity, not volume. Del V by V is equal to del S by S plus del T by T. Now del S is nothing but in 0.4 and S is nothing but 40. Del T is nothing but 0.6 and T is nothing but 5. So all these things you substitute. Del S, S, del T, T, and you will be getting the value as 0.13. So you multiply 0.13 because del V, you know, this V you multiply here. So if you multiply, it will be del V will be equal to your del S by S plus del T by T. Del T by T into V. So that we have done here. You got 0.104. So del V is nothing but the change in velocity. So it is nothing but it is 0.04. So you write down the velocity as 8, which you have found out before, plus or minus 1.04 meters per second. And percentage error is nothing but del V by V into 100. Del V by V already we found out as 0.13. 0.13 100 is 13%. So 13% error is there in measuring the volume. It is a huge error, we have to rectify it. So with this I am finishing this particular one, and next succeeding next classes and all, again I will be discussing numerical problem. Thank you very much.